Okay, good morning, everyone, and welcome to this mnemonic webinar about remote and third-party access practices. As you might know, this is a part of our 6-part webinar series where we present some of the articles from our recently launched security report. In this year's report, you can read about our predictions for 2021 and some of our observations from our 24/7 Security Operations Center. And the report includes articles written by our team of security experts about a broad set of current security challenges and topics like. And previously, we had webinars about security predictions 2021, lessons learned from COVID-19, reducing the risk of insider threats, how to build an enterprise security architecture, and securing third-party dependencies in development. And today we will dive more into remote and third-party access practices. Further, and next up and the last of the webinars in this webinar series, new paradigms for security threats in modern cloud applications, will be hosted on May 6th. And you can find more information about this webinar on mnemonic.no/webinars. If you want to watch previously hosted webinars, you can find the recordings at youtube.com/mnemonic. And now over to the presenters of today. They have co-written the security report article that will be presented today. Adrian, Helle and Konrad Halnum works as security consultants in our system integration department, MSI. And they will tell you a little bit more about their background and what their work in MSI entails. But before I give the word over to them, I have just one practical thing. You can submit questions throughout the presentation. If you're in a browser, you select the Q&A icon from the bottom menu. If you're in the WebEx application, a Q&A panel will appear on the right side and you can enter your questions to all panelists. And we will answer all questions at the end of the presentation. Okay, that's it from me. I will now give the word over to Adrian and Konrad.
So yeah, thanks Alexandra, and thanks for joining us today. We are going to talk about what we like to call gatekeeping today. And first, we'll just give a few words about ourselves. So, I'm Adrian. I work within a group called MSI, which stands for Mnemonic System Integration. I've been doing quite a bit of consulting, and I've mainly been focusing on development for the last year or so. I've been working with a lot of SSL visibility appliances, doing SSL and TLS inspection, and I've also been working a lot on email security. On top of that, I've also done a lot of IRT, or incident response, which is always fun. And it's also shaping some part of my experience with this subject. I started back in 2018, May of 2018. So I've been working here for a couple of years now.
And I am Konrad. I have a few years less of traction within the mnemonic. I started here in 2020, first as a part-time networking operator, while finishing up my master's in programming and networking from the University of Oslo. During the last summer, that was finished, and I joined the MSI dev team with Adrian last autumn, where we tried to focus on creating custom code snippets to further enhance the delivery of the system integrations we do in MSI as a whole. So that's it.
Yeah, so in the article, we present Bill and his conundrum, and Bill is working for a hydroelectric company, and the company is classified as critical infrastructure. That does not mean that this presentation or this webinar will be irrelevant for those who are not classified as critical infrastructure by national authorities. So what we see here is basically a really simple network diagram where we have a on-premise data center, a plant network, or an office network, basically, where we have some laptops, wireless networks, workstations, maybe some servers. And then we have a process network where basically every automated system lives. This should be the most secure zone in the network. Including the on-premise systems and the computers and networks and stuff. We have some cloud providers. Examples here are Kubernetes PaaS platforms, some S3 buckets, RDS, and maybe he's using some other cloud providers for Active Directory, Intune, Office 365, and such. And he also have a lot of remote workers, which we probably have a lot of experience doing right now due to COVID. And he also got some service providers who wants to do maintenance in his network. So some of the questions he's asking himself is, how do I secure the access to these systems and ensure compliance when my most critical machines and software are open to external subcontractors? And how do I keep track of what the contractors are doing on my systems, intentionally or not? Which commands are they running? Are they leaving any software behind? Are they unknowingly using a compromised client that could create a bridgehead for threat actors into my most critical systems? How can I document my routines and provide complete audit trail to stakeholders, including government entities and regulators? So basically, giving access to third-party providers or subcontractors is nothing new, but recent events and past experience show that it's really important to look at how we provide access. So we have a couple of solutions on how to do this, and that's what we'll talk about today.
But first, this is obviously not a new issue, as I mentioned. So we thought we'd just have a brief discussion of what exists and what are the pitfalls when using these existing solutions. One way to give access to your system is, of course, through remote desktop connections or through a VDI of some sort. I'm sure that is fine, except the inherent issues of RDP as a protocol in itself. But as long as you secure that properly and you have proper accounts and all that, it's fine. But you still leave open a connection 24/7, and you don't really know who is using that account. Even though you have given an account to the external contractor, you don't know if that person behind that account actually is using it. Furthermore, this allows the should an incident occur at the subcontractor, they can use this RDP connection into your system, and suddenly you are in the same incident. Even worse in that aspect is TeamViewer clients or the like, where you just have one account, so you lose track of at least a little bit of documentation of who is logging in or not, as you have a shared credential probably on more machines in your network with TeamViewer. And I think water treatment plant in Florida recently realized that this is not a good idea. You also have SSH, of course. This is normal. Can be quite secure if you do this correctly, but there are many examples of non-secured implementations with old server configurations, weird configurations, root login enabled, stuff like that. And again, you sit with this 24/7 open hole into your network that you don't really know who is using and when and for what. Finally, you have cloud storage solutions such as Dropbox and Drive or whatever. If you need some sort of document as a subcontractor into the system, and you don't really have a well-established way of transferring files, it's weird that transferring file still in 2021 is still somewhat complicated to do from machine to machine, and especially in a secure way in this sense. So you think, well, why not just post it on Dropbox and I can download it from the web client? And then suddenly this config file or whatever has some credentials or some information, and then you leave it there for convenience, and then suddenly your Dropbox account is breached, which has happened, and then suddenly your credentials are in the wild. Or you use Pastebin, which is not shown here, which is a very nice way of copying code snippets and the like with nice formatting and whatever. So you post your Nginx config in there and you throw it somewhere else, and then suddenly you leave that there, because of course when it's on the internet it does not ever go away. We're not saying that any of these are principally bad if done correctly, but we see definite areas of improvement, which we'll discuss further.
So yeah, oftentimes we see companies try to solve this issue by creating policies to protect the systems. And some of these policies actually makes things worse, because basically the operators have no official way of either moving files or accessing systems. And we actually have some examples on incidents occurring due to this. So some of you might remember the LinkedIn incident back a couple of years ago, where basically a system reliability engineer had a Mac at home, which he had a open SSH tunnel opened back to Dropbox, to LinkedIn's systems. And someone hacked his home computer and then used that tunnel and stole a lot of data from LinkedIn. So yeah, that's unfortunate. And then we also have actually seen ourselves some places where they use unsanctioned ADSL lines inside a lab environment or such, in order to have a team viewer session from the restricted lab into a home computer or something like that. So basically, even though you have policies in place to protect the systems, those policies might end up damage your systems because it's too strict and it prohibits user friendliness and such. So basically what you get is a rat's nest where you have a lot of wires just entangled and trying to figure out what happened where and why you have or where your breach started or something like that is really hard. So incident response in itself is something that's really hard to do when you have a lot of shadow IT, or when service providers use private Dropboxes, or if they use open SSH tunnels, which are not logged anywhere or documented anywhere. So yeah.
So in this proposed system, we set down a couple of requirements that we will go through in turn, where the first is very pertinent to the case of how to enable the access and in which way the subcontractors should gain access to your system. And we realized that through all of these various processes, if you have OpenSSH or TeamViewer or whatever enabled, you don't really know where and when and who is doing all of these operations in your system. So we need to control that entry point. We need one way to get into the system, and we need to be able to make sure that that way is secure. In our system, we propose to only spin up virtual machines when they are needed, and when they are not needed anymore, we take them down. And we can also take them down forcibly if we notice some malicious intent or activity or communication going through and out of the system. And since we don't have a 24 access opening, it's much more easy and resource friendly to have a strict monitoring on this VM, since you don't need to store 24/7 data. You only need to store the logs from the sessions, and beyond that, you know that they cannot access your system because the whole VM is taken down. And the nature of this VM is simply to be some sort of jump host that allows further communication into your system. But that system can be left isolated, and it will be inside your system, but it will not accept any communication remotely except from one of our VMs. But since the VM is taken down after the session, you cannot reuse anything, any credential given to that VM should an incident occur at a later case. Or if you leave some files on it for an exploit or something, the VM is taken down, it's purged, and when you start again fresh, it is really fresh. Yeah, go on.
Yeah, so the second requirement is access has to be limited to tasks being performed. This means no more continuous and monitored access. So like Konrad said, access is being granted based on certain tasks the requester has to do. Let's say they want to update some PLCs. Then they will basically create a ticket and ask for access from 10 a.m. to 12 p.m. And then the Security Operations Center will, of course, grant that access within that time frame. And after the requested time slot ends, basically the VM is deleted and the connection is shut down. And the same, since we also have a SOC monitoring the entire thing, they basically see what's happening, and they can also close down connections if they see something malicious going on. This approach also opens up to using web portal over HTTP, which again opens another door of possibilities on the monitoring perspective. So basically you can use traditional ADCs or RAP technology to monitor for malicious use and such. Also, as I said, since the SOC is monitoring this 24/7, this basically means that the user can ask for access whenever they want, and the connection will always be monitored. And if an emergency or something else occurs, basically the SOC is there to either help or to solve issues that occurs.
Now, this is all well and nice principles, but it won't have any value if it's not used. And this is maybe an aspect of information security that needs to be worked on a lot nowadays. We need to create routines and practices that people actually want to use. If you have a very secure way or secure your systems in a very good way, but you don't make it easy to be used, people create these shortcuts and we end up back into the world of shadow IT and these undocumented openings and whatever. So we wanted to make sure that it's user-friendly, and through this we created a simple portal where you just request the access Adrian mentioned. The backend handles and the SOC handles the opening, but the end user does not see this. The only response or interaction he sees is a ticket back that says your access is now live. Click this link to access, and you are redirected to a web GUI, and this GUI shows the systems that are available to you to communicate further into your systems. And with this, the client or the subcontractor doesn't have to do any configuration. You don't have to install anything. You don't have to download a VPN client. You don't have to configure certificates or anything. And everything is done through HTTPS, and it's in our control. And hopefully this should be enough to make sure that the users actually want to use it. And that is the best way.
Okay, so the fourth requirement is, should an incident occur, Bull needs to be able to pinpoint what happened, when and where, and possibly also to provide documentation to official government bodies and stakeholders. So because we are monitoring everything and we own the system, we basically can log everything from system commands to network activity to authentication and such. This will then be shuffled back into a CM solution or something like a CM solution. So when or if an incident occurs, we basically have everything we need, everything from logs to network activity and such in the CM solution. It also opens up the door to create ready-made reports. So let's say a customer asks for a report saying how often certain providers ask for access, then we can, of course, create those reports on fly easily, because all that information is available through our platform. The system is also agnostic, which means that it can be used in a lot of different use cases. It's basically just plug and play. If you have a ticketing system, you can, of course, just add a plugin, and that ticketing system can be used with this solution. So yeah.
Now we have a lot of threads. We would like to connect these threads and make sure that we understand how the workflow in the system could be. And as you said, it could be with any ticketing system, and this is the process in this ticketing system, where the user, in this case, the subcontractor, requests access to the system by logging in with the multi-factor authenticated account. So we have a quite good, we can be quite secure that the person who wants the access is the person we have created an account for. We know who this is. The SOC looks at this request and deems if this sounds fishy or not. Usually it doesn't, since, well, multi-factor is at least a little bit good. When the access is live, it could be immediate or it could be scheduled event for tomorrow or whatever. When this is live, the user gets a ticket in response with the link to this web GUI. Next. Yeah, thanks. The web GUI links to this box here. You see user perform maintenance. This is all done in the VM. This is spun up by the back end of our system proposed, which handles all of the VM is patched with an automatic routine with the pipeline. So you get a patch client and all of the credentials are automatically applied to it, and all of the access needs and protocols or whatever further into the system is automatically done. And through this pipeline, you then get the fresh, new, nice patched client for the user. And through this, it also connects the monitoring for the SOC. So of course, the SOC doesn't peek into the user's activity, but we get notifications when something does not seem right. The SOC has a look at this event and checks if this is right. If it's not, maybe it does some further investigation. And if it turns out that this is bad, they, on a click of a button, they can terminate the session where the user is forcibly thrown out, all communication is dropped, and the whole system is taken down. And of course, you can store it for evidence purposes, but this VM will not be ever live again. The other case is when the scheduled time frame is ended. You ensure that the user actually does log out by, again, terminating the session. There is no way for the user to forget to log out, leave the SSH open for a while, or just leave the remote desktop open. He goes to lunch, forgets to lock his computer, his coworker or whatever goes and does something you don't know what is. No.
So in the article, we only describe said system, but we've actually created a system that does exactly this, where we basically use something called Firecracker as a way to create micro VMs on the fly. This is the same technology which Amazon uses behind their Lambda expressions. And then we use something called Ignite, which is basically the lightning bolt icon, to manage those Firecracker micro VMs as if they were Docker containers. So in order to basically create those VMs, we just create normal Docker images and then use Ignite to spin those Firecracker VMs up. So of course, in order to make everything work, we use the Argus platform. The user creates a ticket, the SOC sees this, and they open a new web UI or a terminal client if they want. And then they say, this user with this ticket ID wants access from this period to this period. And then basically, the fast API backend will tell Ignite to start a new VM, and then there will be some magic going on with routing where we use F5. And then the user will basically be presented with an URL. They click the URL, are routed through the FM loop, where we of course do OAuth authentication. So they basically use the same user they use to log into Argus to authenticate into the portal. And then they're presented with an Apache Guacamole dashboard, which supports everything from RDP to BNC to SSH in order to access systems behind that portal again. So the magic here is basically Argus, because Argus is then able to monitor what's going on the VMs, and it will also monitor network access and such. And it will use our magical filtering system in order to find events that should not happen, and then tag those and alert the SOC in their event streams. Yeah, that's basically the gist of it. Of course, if you want more details about how we've actually done this, it's just send us an email. Contact details will follow. Yeah, I think that's it.
Maybe mention why it's nice that we use Firecracker and not Docker images.
Yeah, of course. Because Firecracker basically creates a micro VM, it uses 0.07 seconds or something like that to spin up an entirely new virtual machine. And the problem with using Docker containers is that you only separate the user land, not the actual kernel. So if by chance you can escape the Docker container, you basically get access to the entire host system. The good thing with Firecracker is that if you by chance escape the container, you basically get access, or if you get access somehow to the underlying system, you basically get access to a separated virtual machine, which again is even harder to escape from. And of course, Firecracker is volatile, so basically everything you store in that VM will be deleted after the session times out, or if the SOC revokes access to the system. So this means there is no way for a threat actor to have persistence within the system. Yeah.
Perfect.
I think that's it. That's basically our contact info, and now we'll have some questions, if there's any.
Yeah, thank you, Adrian and Konrad. So yeah, like you said, we're now opening up for questions. And first question is this approach relevant to, for instance, SolarWinds?
Yeah, that's a good question. Well, the answer is it depends. In the SolarWinds case, basically, the application itself got owned, and that's beyond the limits of what this system can do, because we are not limiting system providers or third-party access into the system with the SolarWinds incident. So the short answer is no, it won't help protecting you against that. I think that's...
Well, it's a bit about, it's not the same question, kinda, because in the SolarWinds case, as far as I understood, it was a part of a program that was, as you said, owned, which was part of the supply chain, but not necessarily the actual supply chain, where this is for the subcontractor, an access way for the subcontractors into your system, while it's still a supply chain attack, but it's a different part of the supply chain.
Yes.
Yeah.
Okay, we'll see if we will have any more questions. Okay, we have another question. Sorry, I was 6 minutes late to the webinar. What is the name of the system you have created? Is this something Mnemonic have built yourselves? Could you say anything about the cost?
Well, so yes, we have actually built a system, and we call it Gatekeeper. In order to have a price for it, you have to contact our sales department, since we're not the ones deciding the price. We're just creating the system and maintaining it.
Yeah, so yeah, like Adrian said, you can send an email to sales@mnemonic if you want to know more about price, and if you have technical questions, you can obviously email Adrian or Konrad on the email addresses that you see here. Okay, let's see if we have any final questions before we round off. I think that's it. Again, if you have any further questions that you didn't get to ask here, you can of course email Adrian and Konrad. Well, okay, thank you guys for this webinar, and thank you to the people that joined. Have a nice day and see you next time.
Thank you. Bye.
Have a nice day.